Hey, another factor problem. Now it looks like this is almost impossible because you got cubes and squares and 2s and 10s, but if you, again, factoring though, we can also think about what do they all have in common. You notice they're all divisible by 2, and they also have an n. So what we're actually going to do is we're going to divide everything by 2n first. So what they have in common, put out here. That's our first factor. And then whatever's left over, n squared, minus 5n, plus 6 is there. And then it's like, we're done. But actually not really, because it looks like we can actually factor this with as a product of binomials. So again, we got our n and our n because that's what it's going to look like. Oh yeah, this 2n comes down here. Now this is a positive, so that means they're both going to be the same, and then they're both going to be negative. So boom, 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 boom. Since this is a positive, we're going to add our factors of 6. Since there's nothing out here, we're not going to slide. We're just going to simply factor. So 6 is 6 and 1, and 3 and 2. Now this is actually really tricky because you say, well, 6 minus 1 is 5, or 3 plus 2 is 5. But I said, remember, these are both positive. This is positive. We're going to think of adding. Because another way, if we put a 3 and a 2 here, think about this. Negative 3 times negative 2 is positive 6. But negative 3 plus negative 2 is negative 5. So that's what we want. So if you notice this is a problem, this actually has 3 factors. Or actually 4 if you consider 2n 2 factors. But anyway, you get this one, then n minus 3, which is a whole factor there, and n minus 2. So 2n times n minus 3 times n minus squared is how you factor this crazy problem.